When you write about science in the way I do, you end up running into a lot of the same questions over and over. I like to think of them like jazz standards, the familiar, tried and true pieces that you can riff on no matter where you are. Stuff like, why can you cool down spicy food by drinking milk? It's actually because a protein called casein in the milk breaks down the spicy capsaicin molecules. Or another question is, if the universe is expanding, what's it expanding into? The answer is, it's not expanding into anything. It's more of an expansion of the very fabric of space itself. I say this so I can tell you that one big one on the list is always, why can't we do head transplants? I know the answer. Head transplants require reattaching the spinal cord, which is something we just can't do. They also require having not only a head, but an entire other body you can use for the transplant. I mean, it's hard enough for a patient to get a single kidney, right? I also know that we've tried. I've read quick anecdotes about Soviet scientists operating on dogs, an American doctor trying it on monkeys, and most recently, an Italian neuroscientist talking a big game about doing it with humans. He hasn't yet, and I, for one, don't really think he ever will. But those are just what I know about it. There's a lot nobody knows. We don't know how a person's perception might change with their head on a different body. We don't know how much of ourselves is in our brains and how much of it is everywhere else. And before you start to answer those questions, you've got to answer this one. What even is the point of a head transplant? What possible situation would you find yourself in where that would be your best option? Well, today, we're going to explore that question with a story of that American doctor, the one with the monkeys. It just might convince you that a head transplant is a lot more valuable than it seems. I'm Ashley Hamer, and this is Taboo Science, the podcast that answers the questions you're not allowed to ask. To hear the sordid story of head transplants, I talked to Brandy Schillace. She just wrote a book about this doctor, entitled Mr. Humble and Dr. Butcher, A Monkey's Head, the Pope's Neuroscientist, and the Quest to Transplant the Soul. And the subject of the book kind of fell into her lap.
It all started when I received a phone call from a friend, and I had written a book before on death and dying cross-culturally, and I had done quite a bit of study on brain death. And I'd met a neurosurgeon who worked in trauma. And one day he called me out of the blue and he asked me to come down to his office because he had something interesting to show me. And when a neurologist says those kinds of things, you tend to, I jumped at the chance. So I head down and he works at this is Case Western Reserve University and University Hospitals in Cleveland. And I went to his office and he had an old sort of shoebox. And he puts it on his desk and he just kind of pushes it towards me, lets me open it up because, he wouldn't want to spoil the surprise. And with some trepidation, I look inside and it's an old notebook. And I mean, really like tattered, well-used, probably from the 1950s, brown cover, lots of graph paper. And as I'm flipping through it, it's got all sorts of notes in cramped handwriting. And it has words in it like mouse brain and isolated brain and EEG, things like that. There's also little flecks of discoloration in the booklet, which I was later informed was blood. So I'm looking at this blood flecked notebook, and I asked my friend, I was like, what is this? And he said, well, it's the lab notebook of Dr. Robert White, who performed the first head transplant on monkeys in the 1970s. And I know I've told this story 100 times, but every time I still feel the same way about it, because there's so many words in that sentence that just are mind-blowing all by themselves. Head transplant, monkeys, 1970, all together in one place. So I was really hooked after that. And what had happened was, he died in 2010, and he'd been nominated for a Nobel Prize, a lot of interesting things about him. There was an entire family archive that nobody had really been through. And so I was offered this opportunity to explore his life. But what ultimately happens is it is about his life, but it's also telling the story of 50 years of medicine from the earliest organ transplant to today. And the massive changes that have occurred, partly because that time period was also, civil rights, animal rights, the fall of the Soviet Union, the rise of these separate states over there, all kinds of different tensions that you weren't expecting, changes in ethics, changes in our understanding of culture and race, and all sorts of things happening also in that 50-year period, while our technology, of course, is getting better and better and even more mind-blowing as time goes on. So the book is both a biographical look at a human being's life and a look at a really strange, interesting, tenuous, fringy Cold War period of time in science and medicine.
Here's the thing. I've read up on head transplants so many times. Why did I never know the details about this guy?
So one of the other things that has happened in that 50-year period is the kinds of things that we as a public might support have changed. So in the beginning, this was Cold War medicine. And Dr. Robert White's rival, Vladimir Demikov in Moscow, was also working on transplanting heads. He was using dogs. He was creating two-headed dogs and other strange creatures. And you might not be able to get a lot of people behind the idea of taking heads off. As a matter of fact, taking heads off upsets people. But this is remember, Cold War era science is different. We didn't know what was going on behind the Iron Curtain. We didn't know if they had the ability to restore life. They were releasing weird film footage pieces that made it look like maybe they were doing some stuff that, seemed impossible. And you even had explorations into the occult, all kinds of things. It's worried that people had telekinetic abilities that could control rockets. Believe it or not, people worried about that. They wondered if that was true. So at that period of time, a lot of money was available for people, big funds available for people like White who wanted to do some experiments that seemed a little bit maybe off grid, right? That's not the way we are today, though. So 50, 60, 70 years later, and you're not going to walk up to one of the National Institute funding bodies and be like, hi, I'd like to take some heads off of things and put them on some other bodies. They're not going to be cool with that. So some of the things that I think have transpired is White's peak of popularity just happened earlier. And then as he aged and as we as a society became less comfortable with some of his animal experiments, he was using primates, and that's quite upsetting to a lot of people as well, that I think the spotlight was sort of like, well, let's not focus on that. As a matter of fact, when he was nominated for the Nobel Prize, it was for therapeutic hypothermia techniques he developed. And the man who nominated him, Joseph Murray, who performed the first successful kidney transplant, even said to him, like, let's not talk about the head transplant. Could we just just put that in a box? We don't really want anyone to be reminded of that. So I think some of it was an actual semi-intentional turning away from this story. And that's partly why we hadn't heard about it.
Gotcha. So this is like a Marky Mark situation. Mark Wahlberg wants to be known as Mark Wahlberg, the actor now, and not Marky Mark, the rapper of the early 90s hip hop group, Marky Mark and the Funky Bunch. Except in this case, instead of trying to make the public forget he was in a group with someone named Hector the Booty Inspector, He wants people to forget he performed a head transplant on a monkey. Same difference, really. But to really understand what was happening with head transplants at the time, you need to zoom out to see what was happening with organ transplants in general. From what you write, it sounds like there was like a time in history when transplanting organs at all was seen pretty much as horrifically as transplanting a brain. Is that right?
Well, yes, I like to say that my book re-weirds some things that we take for granted today and makes other things which seem weird to us quite normal. Remember that we could not transplant organs until the 50s. That's late. It's new. It's still a new technology. We don't think so. We think you tick a mark on your driver's license application and that's it. We are not shocked anymore that people's lives are saved by organ transplant. But this was science fiction for a long time. Because let's face it, the concept that your heart could beat in someone else's body and keep them alive, that you could even get it out in such a way that it would still be living when it went in the other body, that's bizarre. I think we have to take a moment and remind ourselves how strange that idea really is. Or, for instance, people whose children have donated organs because they've died, and now their child's heart is beating in another person's body. That's a meaningful question-raising event, and it's something we shouldn't take for granted. So it was very strange, and it was very dangerous. Up until the first successful kidney transplant, it's not that they hadn't tried to transplant organs, it's that they had tried and failed. The body rejects those organs. People would die of infection or gangrene. I mean, this is not a pretty situation. So when you are agreeing to be part of one of these surgeries, these early surgeries are not all successful. So it's also scary. You don't know what's going to happen. Joseph Murray at the Peter Bent Brigham in Boston, he was concerned. They had twins. That's why they knew it would work. They even tested this by grafting some skin from one twin onto the other twin to make sure that the tissue wouldn't be rejected. But ultimately, when they went into surgery that day, they were going to take one kidney from a healthy twin and put it in the body of an unhealthy twin. And there was a possibility that both men might die in this surgery. I mean, it was a low possibility, but it was quite dangerous.
Organ rejection happens when a patient's immune system treats the new organ as an invader. And I mean, it kind of is. Your immune system is really good at telling the difference between your own cells and foreign cells, which is why it attacks bacteria and viruses that could make you sick and leaves your own organs alone. It makes that distinction based on antigens, which are cell molecules that can trigger an immune response. Your own antigens are A-OK. Everyone else is suspect. So when an organ joins the party without the right antigens, the immune system puts up a defense, which can sometimes kill the patient. The first drugs that could suppress the immune system and prevent organ rejection didn't come out until 1983. There was a long time when organ transplantation was incredibly dangerous. But while people were fretting about rejection with transplanted organs, nobody realized that the brain was different until Dr. White came around.
You know how I just said that bodies will reject organs that don't belong there unless you use immunosuppressant drugs? That's not true of the brain. It turns out that brain tissue won't be rejected by the body. And he found this out because he was isolating brains. And I need to explain what that is because it sounds very clean and hygienic. You know, it sounds like a nice brain floating in space in a kind of cartoonish, pinky way. But in fact, it means getting a brain outside of the head while it's still alive and making sure it stays alive the whole time. And we have to just, sit with that for a minute because I realize how strange that sounds. Essentially, he had to take the brain's very greedy. The brain needs lots and lots of oxygen. And if it doesn't get it, the cells die. And if the cells die, then you suffer brain damage and death, ultimately. So he hypercooled the brain. This is where that therapeutic hypothermia comes in. And he hypercooled it. It needed less oxygen, but he still needed to provide it with blood. So he used a donor animal. So he's basically unplumbing the head from its own venous fluids and plugging in the venous fluids of another animal until he just has a head being fed by blood. And then he removes the tissues surrounding the skull. So it's still alive. It's hooked up to EEG and it's still thinking. I'm going to use air quotes on that, but it's still sending out brain signals that are popping up and down on that graph paper, just like it would inside a skull of a monkey. But this brain has just lived outside of its body. And that's peculiar. To me, that's probably the most shocking thing, that your brain can outlive your body. We talk about brain death. That's where your body lives longer than your brain. But apparently your brain can live longer than your body. And that's just a weird idea. So that's how it started. Well, he took one of those brains to keep it alive. He felt that it would be easier if it were inside another animal's body. So using a dog's brain, he opened an area in the neck of another dog, plugged that brain inside the neck of a dog, and plumbed it up, with the proper arterial, he did all the things that you need to do to reconnect it, and sewed it back up. And the dog's body didn't reject the brain. So it just had this other brain living in its neck. And they realized that probably because of the brain-blood barrier, potentially, it doesn't get rejected the way a heart, a lung, a liver. So when we think about the old Frankenstein movies where they're plopping brains into another body, apparently that would, technically, it would work. The body wouldn't reject it once it was in there.
But this brain was basically just a lump of flesh that he kept alive. Keeping a brain alive and making it think are two different things. How do you prove that a brain is thinking?
That actually ended up being the tricky bit, because while you can re-hook up the various blood vessels and things that you need, reattaching nerves and things that's a much, much harder thing to do. And so while the brain can send signals to graph paper, that graph paper can't tell you what it's thinking. And a lot of people were actually quite skeptical. They were like, I don't know that really counts as life. That's okay. Dr. White was not discouraged. He decided that's fine. He would find another way. And that's partly where the head transplant idea comes from, is he realizes if you just keep the head alive with all the face bits in place, then you can show people that it's moving its eyes, its mouth, its nose, it's listening to sound. It's still that the brain's functioning just the same way it was when it was still attached to a body. Now it's just not.
Oh, just keep the head alive with the face bits. Just that. You'd think they'd prove the brain was thinking by, using new technology, brain scans or something. Not actually keeping a disembodied head alive. What a world.
That becomes the next step. And it's partly to prove, he was trying to prove to them that, yes, this is a thinking brain, not inside a body. This brain is still thinking. And that's an important step forward for White, because he wanted brain death to be considered real death. And today we largely take that for granted, that yes, brain death is death, and you get a death certificate with brain death. But it's not a definition in a way, it's a checklist. So what most people don't realize is we don't have like a widdly wee from Star Trek that you wave over someone and it goes, yep, brain dead. No, it's a checklist that a doctor has to fill out and somewhat subjectively decide that, yes, this brain is now dead. And so, a flat EEG signal is helpful, but it isn't the only thing that they have to look at. Are there reflexes? Do the eyes dilate? Does, all sorts of things that they have to check.
In fact, the definition of death can change depending on where a person dies. In 1981, a presidential commission recommended that all U.S. states adopt the Uniform Determination of Death Act, or UDDA. The UDDA states an individual who has sustained either 1, irreversible cessation of circulatory and respiratory functions, or 2, irreversible cessation of all functions of the entire brain, including the brainstem, is dead. That was to make sure that all states considered total brain death to be the definition of death. But Louisiana and Texas never adopted the total brain death clause in their hospital definitions of death. And North Carolina weirdly left out the heart and lung clause. A pronouncement of death has never really been as clear-cut as it is on TV.
So even today, it's somewhat subjective still, even though it's pretty clear. Think about what's happening in the 1950s and earlier, when suddenly people are having to make these determinations, and there's not the same kinds of techniques and history behind it that we have today. So suddenly people are going, well, I want to take this organ out of this person. and I want to put it in someone else, well, you better be sure that they're dead, that their brains at least are dead. If you're wanting a beating heart donor, and that's what they called it, brain dead victims, their hearts still beat because it's part of the autonomic system. And that means you can't breathe on your own. So you're being kept alive with machinery, but your heart is still beating, and they want that heart still beating in order to put it in someone else. You can understand why. Because as soon as you die, tissue begins to die as well. You don't want necrosis. But then how do you know someone is dead enough? And that becomes a really big deal. So some of White's experiments with brain life was sort of the yin to the yang of what is brain death. And he felt, as they're defining it on this side, he's trying to find the definition the other way around.
And that is when he attempts the historic feat that he'll later hope the world will forget about. He begins the process of transplanting the head of a monkey.
I will start off by saying that in the book, and also as I'm going to describe it, I'm going to do my best to keep this in a very clinical kind of fashion. There is footage, and I watched it, and I won't lie to you. It's disturbing in part because when you look at a primate, it looks a lot like us. It's our nearest evolutionary relative. And so I just want to start off by saying some of this is upsetting to a lot of people. But essentially, White, again, he wanted to prove that brains could outlive their bodies, and that the brain was essentially you. And that once that body was gone, you were still you in there. And that was very important to him. So he started off with rhesus macaques, and they're somewhat small, mid-sized monkeys. And he took 2 of them. And the idea was to have the surgery so well timed. You had 2 teams working to prep each monkey. And then you'd bring them together ultimately for that transfer. Now, it's so complex that White literally put marks on the floor, almost like dance steps, in this laboratory to make sure that nobody would be in anyone else's way. And the first stage is not, you can't just like swap heads. It's a lot more complicated than that. You have to be able to attach the head still to all that venous fluid, still to the blood that's oxygenating it in the interim period before you take the head and swap it over to another body. So what they do is they take each monkey and they extend it by disconnecting the spinal cord and attaching the veins to much longer tubes. So in the book, I describe it as it's a bit like the old school telephones, where the receiver is attached by a bunch of coily wire to the telephone. And so they created these monkey telephones where the head is resting on a cushion, and then these coils of tubes are feeding blood from its body to its head. So now once they got to that point, they could bring both monkeys together in a single lab and begin the process of unplugging one and plugging it back into the other, unplugging and plugging, until ultimately they had monkey A's head on monkey B's body. Then they shortened those tubes, reconnected the neck, sewed up the tissue, and waited.
Over time, the beeps from the EEG machine that signaled that each monkey's brain was alive, in monkey B, they slowed to a stop, just as you'd expect from a brain stripped of all its fluids. Now, it's all up to monkey A.
Now, this has been hours. They start before dawn. It's late. People are sweat-drenched in this lab with lots of dials. They have to have constant monitoring of the body processes of the monkey to make sure it's not going into shock, that the blood's still flowing, that it's the proper temperature. White literally built machines specifically for this with designs he's sort of based on a lemonade circulator. And he had this big lab full of people watching all of this. Now he's smoking a pipe. He smokes a pipe constantly through these surgeries. So he's smoking a pipe. They're watching the clock. White, bald, slightly chubby with his big black frame glasses and all of his team surrounding him. And they're just watching this sleeping anesthetized monkey, and they're waiting for a sign. And suddenly one of the younger sort of aides, doctors and nurses says, "Oh, I think I saw an eyelid flutter." And everyone gathers around and they wait. And slowly this monkey wakes up. Now, it's not going to be the same. It's now paralyzed. So if you sever that spinal cord, even though it's attached to a body, even though that body's feeding the brain, it can't move its limbs. So you can imagine it's confused. It doesn't really know what's going on. It's blinking. It's looking around. It sees Dr. White. It immediately tries to bite him. The monkeys did not like Dr. White. It tries to bite him. So this is a head. Remember, this is a head that is being kept alive on a life support system that is another monkey's body. And it is trying to bite. It's watching them walk around the room. It's attempting to make noise. It can hear sounds. They end up feeding it a grape it eats. This is a monkey that is, for all intents and purposes, still a living creature. Now, is it the same as it was before? We can't ask the monkey. We don't know. But for all intents and purposes, White was able to prove that that brain inside that head, its body had been thrown away, was still alive. And that is the breakthrough of that surgery. And there were a lot of people very, very unhappy that he was doing this to monkeys. And many people asked, what was the point of it? Like, why were you doing it at all?
What was the point was what was the point?
Well, he did have reasons for doing it, but the reasons are quite complex. So for one thing, you have to understand that for White was Catholic. And White believed that the brain was the repository of the soul. So to some degree, he felt he was performing a sort of soul transplant. He was proving that the self, the soul, the animating principle, what made you you, was inside the brain. And that was very meaningful to him. So there's reasons within reasons for this. The other is, as I said, he was trying to prove that consciousness could survive the bodily death, which was like the inverse of brain death. But there's another reason. It is very rare that surgery protocols are built around primates, using primates, unless you plan to perform that surgery on people. And when I tell this story, a lot of people say to me, well, but it's not like he was planning to transplant human heads, but he was. Part of the reason that he was doing this surgery was because he thought it would be a way of saving people's lives. And if that seems a bit hard to get your head around, sorry for the pun, it is, because of course you're thinking, what kind of life would that be?
I mean, think about it. You're paralyzed from the neck down and you're not even in your own body. Brandy didn't see the point at first either.
To begin with, I absolutely saw no point at all to doing a head transplant on human beings or probably anything else. I just didn't see the point. But through the course of research, I encountered someone named Craig Vidovitz. And Craig Vidovitz, he's since passed on, but in 1999, he sought Dr. White's help because Craig was tetraplegic. He had been in a diving accident as a young man, and he lost the ability to use his arms and legs. He went into the hospital, expecting therapy, only to discover that, I don't want to say that people gave up on him, but in a way, they were like, well, you've got a really bad injury. There isn't much, that we can do for you. So he ends up leaving the hospital and putting himself through his own rehabilitation program. He builds a specialized wheelchair for himself. He's very inventive and creative. He develops a sort of cast for his arm so that he can still write, even though he has almost no movement in his arms, but he has just enough shoulder movement that with this special device, he was able to write, sign his name. He ultimately ends up living a quite full life. He's married, he has children, he owns his own business. But as with many tetraplegic patients, his organs had begun to fail. And unfortunately, also because he was paralyzed, he wasn't considered a good candidate. And for Craig, he felt that was almost like the medical establishment was saying that disabled lives didn't matter as much as abled lives, that his life was somehow not worth saving because he was paralyzed. And he was really upset, as I think he had a right to be with that. Some of this, I believe, has changed now, but at the time, he wasn't able to get on any lists for transplant. And they can be long lists. So he approached Dr. White after seeing White on television talking about transplants. And he said, I'm willing to be your first patient. I want to live. I don't want my body to fail me. Up until that moment, I think I had just simply thought there was no reason to have a head transplant. But listening to Craig in interviews talking about how he felt about his life in a world where everybody kept saying, that only abled lives should have in other words, he was already tetraplegic. The fact that he would be tetraplegic on the other side of the surgery wasn't off-putting to him. Stephen Hawking gets used as an example by White sometimes too, saying, is that not a life worth saving? So I was moved at that point to think, well, some of the ick factor driven by ableism, is that partly why we don't want this to be a thing?
Dr. White, for his part, fully believed that everyone deserved saving.
That's where it's important to understand the rest of what White did for a living. He was a neuroscientist, but he was also a neurosurgeon. He worked at Metro, which is a trauma hospital. He saw people in terrible circumstances, car accident victims, teenagers who'd been hit by drunk drivers, gunshot wounds. He saw people whose bodies had been massively traumatized, who had become paralyzed, who had had all these things happen to them, but the brains were still good. And it really just tore him up that people died when their bodies died. If you had cancer or you had a wasting disease or, some sort of degenerative disorder, that it would take you even though your brain was still fine. So again, because White believed brain equaled life, that the signals on that graph paper meant you were living, then he felt that you ought to be able to do anything necessary to save that person's life. That's what organ transplants are for. He didn't look at the head transplant for humans as a head transplant. He looked at it as an organ transplant where you were getting all the organs at one time. And that was really what was driving him in these experiments. But there are other questions to consider. For one, are we just brains? I think not. I think our bodies are quite important to us. I think our bodies are important for our identities. Think about the LGBTQ community, about how important the body you're in is and how it looks and how it functions is to the way you see yourself and your psychology. That people get dysphoria and other things because of that. So to say that somehow the body doesn't matter, that's probably quite naive. You also have neurons in your gut. You've got all kinds of hormones that also influence your personality and who you are. So we don't know whether you on the other side of that is still really you that went into the surgery. We don't have answers for that. And one of the criticisms I'd also heard about this was that we have a shortage of organ donors and people are on long waiting lists. If you decide you're going to use an entire donor body for one person, when it could have saved a lung transplant, heart transplant, liver, are you saying that one person is worth four? And who decides? So the issues are really knotty. So I don't think it's just a matter of perspective, but I certainly found myself suddenly more open-minded to the concept after listening to someone like Craig explain his own experiences.
So did Craig and Dr. White ever get to try out that human head transplant? They never did, but not for lack of trying. They couldn't gather the funds or get permission from a hospital to perform the procedure. Craig died in 2017, but he lived 7 years longer than the doctor who planned to save his life. So clearly, there are good reasons to transplant a head, even if it will result in being paralyzed from the neck down. But could we ever get past that? Could we ever transplant a head onto a body that brain could control? I feel like, the big elephant in the room for head transplants is the spinal cord. Like, we cannot do that, right? Like, we cannot connect a spinal cord.
Not now, not at present, no. As a matter of fact, most of the research that's out there that interests me anyway, BrainGate is one, there's a couple other ones, are looking at ways of bypassing the spinal cord rather than trying to fix it because it is so complicated. For a while there had been some hopes for PEG or polyethylene glycol, stem cells, and other things of trying to get neural pathways to regrow.
Polyethylene glycol has potential in reattaching nerves because it's surprisingly good at fusing cells together. PEG is a molecule that, in essence, loves water molecules. That's why you'll find it in everything from laxatives to antifreeze. In cells, it can dehydrate and break down their membranes, which encourages them to combine together. That's why it shows promise in spinal cord injuries. Every demonstration of its power so far has been on brand new injuries in mice and dogs, though, so it's not clear how successful it would be on older injuries in humans. And that's just talking about partial spinal cord injury.
But what it seems so far in the research that I've seen is that that only works if there hasn't been a complete severing. It's if you've just 100% cut through, so far nothing has allowed that to regrow. On the other hand, we are working on strategies for just jumping over that gap. And that works better or worse depending on what animal you're talking about. But a lot of the experiments have been done with four-legged animals and monkeys, and which are semi-four-legged. And what they're doing is they're trying to find out if they can wire the part of your brain that controls that muscle directly to the muscle, as opposed to having it, using technology through computers and electrostimulation and all other kinds of technologies to try and get your brain's message to the proper places, even though those pathways are broken at the source. There have been some really interesting things that have happened as a result. One of my favorites, and I talk about this in the book, is where they're electrically stimulating people to try and get them walking again. And these are cases where the spinal cord is damaged severely, not cut through. And what they found is after artificially stimulating the legs to walk or to move, the patients started getting some feeling back, almost as though the practice in that arena re-stimulated bits of their own body to connect to neurons and things to connect again or to find new pathways. So they're still studying that, but I find that fascinating. It's incredibly complex, however. One of the things that they have not been able to do very well is operate your hands. Humans are astonishing with our hands and fingers, and we just do not appreciate how much of our brain is involved in getting us to do something as simple as picking up a pencil. So it's not a 1-to-1 ratio. It's not going to be simple or easy or soon. But if we ultimately overcome paralysis, I think it's more likely that it'll come from skipping injury sites rather than from healing destroyed spinal cords. Jumping off of this research, I was fascinated to discover what's being done in terms of closing the loop, which is what they call that idea that you can get the brain and the body to communicate that way. I think it's only a matter of time for a lot of that technology.
Is that the last step? Is that the last hurdle for head transplants? I mean, barring the philosophical objections.
I don't know. One of the things that I hope people walk away from my book with is a question rather than an answer. And that is not just who are we, but where are we? And I think until we have answers to that satisfy us, I'm not sure that replacing our brains in a body or in a machine or anywhere else is really going to replicate the experience of moving yourself from one place to another. We're not really hard drives. We're complex, composite beings of hormones and neurons and, bacteria colonies and all sorts of symbiotic relationships that we don't actually see in the way our genetics work, our genes, our DNA, the messages that are being sent at all times from our neurons to these little tiny worlds that are inside of us. I don't think that you can discount how important that composite body is. And so I'm not sure that I think, yes, you could probably retain some of your consciousness and move it somewhere else. I think that is probable because at least it seemed that way for the monkey. The monkey was a monkey. Was it the same monkey? Possibly not, but it was a monkey. So, again, knowing that you can transplant some part of your consciousness doesn't necessarily mean that what you end up with is you. So I think that there are more questions than answers. And of course, that's the value of science, isn't it? To ask gritty, difficult questions.
Thanks for listening. Taboo Science is written and produced by me, Ashley Hamer. The theme was by Danny Lopatka of DLC Music. Huge thanks to Dr. Brandy Schillace. You can find a link in the show notes to pick up her fantastic book, Mr. Humble and Dr. Butcher, A Monkey's Head, the Pope's Neuroscientist, and the Quest to Transplant the Soul. Brandy has also founded a virtual event series that should be of interest if you like this show. It's called The Peculiar Book Club and features talks with authors of books about weird history and strange science. You can find a link to that in the show notes too. If you want to keep up with everything Taboo Science is doing, you can follow the show on Twitter and Instagram. Just look for Taboo Science, all one word. Or just visit the website to find everything all in one place. That's tabooscience.show. The next episode will be out in 2 weeks, and it's all about the taboo science of money. Stay tuned.